This is worked example 3 from exercise 9.01 on page 399. Amelia currently has $6,000. She plans to go on an overseas trip in 5 years' time, so she invests her money in an investment annuity that is averaging an interest rate of 7.2% per annum, compounded annually. If she deposits $3,500 each year, find the amount available for her overseas trip. All right, so this time we're going to actually find the A to the N longhand, and we only want to find one value at in 5 years' time. So it's not so tricky, this one. The formula that you need to use, the theory for this, is on page 398. So the value of an annuity is given as A, the amount at any time, or at n number of months, is equal to the initial amount times R to the N plus D times the deposit times R to the N minus 1 divided by R minus 1. All right, so we know here that the values, A to the 0, how much does she have initially? She has $6,000. D is an easy one to pull out. She deposits $3,500. This time it's compounding annually and she's depositing annually, so that's really nice. So our I is equal to 7.2% as a decimal, which is equal to 0.072. And our R, of course, is equal to 1 plus I. So 1 plus 0.072 gives me a value of 1.072. Now, any other values in there that I need? I think that's it. I've got an A, O, I've got an R, I've got an, N. N is 5. Compounding annually, and it's for 5 years, so 5 times 1 is 5. So then we just put those values into our formula and come up with A at the end of 5 years is equal to 6,000, still in the previous one, times R, which is 1.072, to the power of 5, plus D, which is her 3,500 she adds each year, multiplied by 1.072 to the 5th minus 1 over R 1.072 minus 1. Now I would write this again as two separate sums. I would do this on my calculator. And the first set here is 6,000 times 1.072 to the 5th power gives me $8,494.25. And this section here, the 3,500 times 1.072 to the power of 5 minus 1 over 1.072 minus 1. Put that in my calculator, I get $20,208. How many cents? 0.65. Let's just leave that. So just sliding up a fraction so I can finish that off. At the end of the 5th year, Amelia would have a grand total of $28,702.32. So you would write a nice sentence at the bottom of that one because they gave you the problem as a word problem, and just zooming in so you can see the whole lot. They gave it to you as a word problem, so give it back to them as a word answer. I'm not going to scratch a word answer or a sentence answer across the bottom because it will just be messy. All right, good luck with the questions in this chapter.